Like a quick question for Martin, I guess. You know, the B612 Foundation has been trying to raise money to put something, I'm not sure exactly how far in, but deep, you know, in the inner solar system, so it can look out. It's not blinded by the sun. But they're looking for planet killers. The question is, I guess, would that be helpful in terms of prospecting as well?
It would be about equivalent to the near-Earth object surveyor. Yes, they were going into a Venus synchronous orbit. They were going around, and that way they will lap the Earth and find hit the dinosaur killer type asteroids that are hidden behind the sun in almost perfectly Earth-like orbits, just gradually approaching us. But they could not get funding, unfortunately. So, from our point of view, I think the job that will be done by the Near Earth Object Surveyor is excellent.
I'll never say never. Maybe they'll.
Well, yes, but there are alternative things. They're pursuing, I think, what's it called? Synthetic tracking to find faint asteroids right now. It's probably what Joel is doing, but I wouldn't want to speak for him.
Yes, we're using a different, more computationally efficient shift and add method. The Sutter Ultra Survey has several other innovations in it that involve the use of compound telescopes in a rotate, stop, rotate survey pattern. We've innovated a new orbit for asteroid discovery, which we call pseudo-geocentric. It's a slightly elliptical heliocentric orbit that causes the spacecraft to circle the Earth in a retrograde fashion outside the Hill sphere. And Jedicke's calculations suggest that Sutter Ultra will be able to discover each year 350 times more asteroids than have been discovered since the first asteroid was discovered. We're really gratified that NASA has chosen to fund us to do a tech demo of that, which will involve 4 12.5-inch f4 Newtonian reflectors configured into a single compound scope with SCMOS detectors and processing with GPUs. And with that demonstration, we think that we will be able to justify and sell a really breakthrough asteroid prospecting system, and which will find, you know, it will prospect essentially all the small asteroids in highly Earth-like orbits. Also, it's a multi-band system for doing asteroid taxonomy, and it includes an infrared channel for doing sizing. And we think you don't need to visit asteroids to prospect them.
Okay. Yep.
But we also understand that that's controversial, and it's a very complex subject.
I guess this is sort of a panel question. In terms of economics, you know, I've been thinking about this for like 30 years. We always have, you know, problem's always been it's expensive to get stuff into orbit. And that problem is getting solved finally. But the question's always been, and George, you know, had some charts on it, but it seems to me there's always going to be an issue of, you know, if launch prices get really cheap, then at some point it doesn't, if you can get stuff to, you know, to LEO very cheaply from Earth, you know, at what point does it become economically, make economic sense to get resources, to get propellant, say from the moon to LEO? You know, will that ever happen? It seems to me that it's basically something we can't know the answer to until we get out there and start doing it and see what the market says. But I'm wondering if people have thoughts on that.
Yeah, I think there's the, you know, economic reality. There's also the kind of practical logistical piece. I mean, by some, you know, forecasts that I've seen, a Starship is a 10-to-1 refueling ratio in orbit. So, you know, how practical, even if it makes economic sense, how practical is it to fly 10 Starships up to refuel everyone that's, you know, run out of fuel? So you have to certainly look at some of these other things from a timing perspective, right? You know, if you've got to refuel one in that manner, yes, maybe it's cheaper, but what does that do to mission timelines and cost and efficiency from a business perspective? So I think it's more than just kind of the raw calculus. You know, timing is the most important thing for business, and so that's a crucial factor. And really, you know, creating the new supply chain off planet has to be looked at from other methods. It's really a gating factor that enables all of the other activities to happen in a scalable sense.
Any other thoughts?
Yeah, I think it's very common. I get this question a lot from people who've spent their careers in the government. From the private sector perspective, financially, there's the issue of market elasticity. And that is, as the cost of doing something drops, if it has certain market elasticity, the scale of the market increases more than compensating. Okay, so that's a little abstract, so let me put it in plain terms. There's an island off the coast of California called Catalina. At Catalina, they have wells where you can get drinking water. The reason there are wells on Catalina is because it's cheap to get to Catalina. If it cost $30 million to get to Catalina, then there would only be one scientific expedition there every 10 years, and they would bring bottled water. But because it's cheap to get to Catalina, it makes a lot of sense to harvest resources locally, because the market grows. And so our analysis is that every time launch cost goes down, it opens the prospect of vast new markets and vastly increases the need for space resources. Put it another way, it's completely ridiculous to consider building a hotel on the moon at $10,000 a kilogram to low Earth orbit. At $500 a kilogram to low Earth orbit, it makes sense to build a scientific outpost on the moon. Once you have that outpost, you obviously want to harvest local resources. When you're doing that, the transportation costs to get to the moon drop enough that you can deliver people to the moon for $2 million, at which point it makes sense to open a hotel on the moon and have 1,000 people living and working on the moon. So reducing costs always increases consumption.
I often think about the example of Alaska, where despite the fact that they have cheap oil there, they have to import gasoline because they don't have a big enough population to justify building a refinery. I'm wondering if we're going to have those kinds of issues in space.
Another way to put it is the global logistics supply chain for gasoline is so efficient that it doesn't make sense to build one locally. But they do harvest the resources there.
Well, I'm wondering if there'll be some equivalent where the resources are harvested on the moon, but processed someplace else.
Well, I completely agree with the assertion earlier that the market will determine, and the market will measure a parameter called market elasticity, and that will provide the answer. So whether we sell propellant from the moon and asteroids to low Earth orbit is an open question. With GEO, it's not an open question. And anywhere else, it's not an open question. I think we'll certainly sell propellant in those markets. And we've already taken an order for $750 million for, I won't say how many tons, but many, many tons of water in GEO to support LEO to GEO transport.
And you can see the economics of, you know, where to beneficiate and how much active in the current terrestrial mining industry. And it very much depends. It depends on the technology. It depends on the mineralization. It depends on where the resource is. And, you know, each mining effort is optimized on doing that part of the process that makes sense for the moment that it's capitalized. And that might not be the same answer 10 years later.
I agree. George and I had a nice conversation going in the chat channel about should you upload water from the surface of the moon or LOX hydrogen? And that's a perfect example. I mean, we don't really know. There are good arguments on both sides.
And it's going to depend on the rest of the infrastructure. You know, is power cheap on the moon or is it expensive? As an example.
I think we're not thinking big enough, really. In my view, I think the way we need to think about all of this is, what do we do here on Earth? we fundamentally, people don't go out for resources in isolation. What we do is build towns and cities and communities. And we do that as a function of the availability of the entire transport equation, of the infrastructure, the propellant, the needs, the business model, and the capability. And I think the equation of how we've been looking at space is about to change, to flip on its head in every way. In that we, over the last, or all our lives and over the last 70 years, we've looked at space as a domain that's accessible through a pinhole of transportation difficulty. If the types of architecture like Starship emerge and the price to low Earth orbit drops to hundreds of dollars a kilo this decade, and potentially less as competition emerges, all of the domains in space and in celestial bodies may get closer to how we view transit to the West Coast, to, for example, in 1850 or 1875, and then in 1900, and then in 1925. I think over the next 2 to 3 decades, we will see we talk of Earth as a village. We may see cislunar space as a village in the next 10 to 20 years in terms of accessibility, and then all the things that lots of people want to do. And then we don't have to discuss the intricacies of, are we talking about propellant or water in this location or that? The biggest problem we'll have is, how the hell do we meet demand? And for 100 different products and services.
Well, historically, towns have been created around transportation. You're on a river, you're at the mouth of a river, you're at a harbor.
Exactly.
And something I've been working on recently is, again, Starship changes everything. I'm starting to think of equatorial LEO as Earth's natural harbor. Because you want as much stuff in one orbit plane as you can get it, just for sustainability and space traffic management reasons. And it's the cheapest place to get to. The only problem with it, and the reason we've never done it, is because we don't have launch sites at the equator. But with Starship, maybe we can do that. Maybe we can you could build just a steady pipeline of material into space, into equatorial LEO, and then figure out how to get it to the other places it needs to go from there.
Sorry, go ahead.
Yeah, I think the benefits of equatorial LEO, especially with reusable second stages, are not understood. They're massive. It's very hard to make an effective reusable upper stage in any orbit other than equatorial LEO. But once you do it in equatorial LEO, full reusability, the cost collapses. And there are complex reasons for that have to do with orbit phasing and orbital dynamics. They're complex at the undergraduate level.
I certainly think that like a lot of this thinking is based on, this tie back to Earth, but I think we're on the cusp of a paradigm shift where we move to a space-to-space economy where we're no longer tied to Earth, right? And a lot of these activities, a lot of this demand is demand that's going to be generated in the future purely in space, that it's not coming from Earth at all. And these become kind of self-sustaining organic economies that are living organizations unto themselves. And so, it's clear that we're not there yet, but we are on the cusp of that, really producing any supplies off planet, whether it's, oxygen, water, hydrolox, whatever, is the first kind of step to that. Once you get past that, what it opens up is an entirely new realm of kind of growth catalysts and possibilities.
So look, I mean, on this call, we've got, at least I'm in the company of a brains trust of folks who are covering the gamut of space mining, the economics around it, the legal aspects around it. What do we do when we're there? How do we get there? both for the moon and asteroids. When do we, if we go around the table a bit here, when do we think the first real sustainable space mining business opportunities or revenue streams from sales of product might occur? And I'm not talking to NASA, I'm talking to a third-party commercial entity.
I'll start.
Yeah, go for it.
So I am a robot guy. I started my career in interplanetary robotics at the Jet Propulsion Lab. I've always been a robot guy. I'm kind of scared about human health and safety in the space environment. It's an extreme environment for which mistakes can have fast and severe consequences. Having said all that, I don't think we're really going to see exciting, scalable activities happen in space until the human presence increases by like something approaching an order of magnitude. Instead of a half dozen humans in an American space station and a couple more in a Chinese space station, I'm excited about multiple LEO destinations, because multiple LEO destinations means more experimentation. It means more throughput of ideas and ability to try them, perhaps in more competitive environments, perhaps in more natural environments, depending on that. And one of the reasons when we founded Planetary Resources, we focused on asteroids was because the US in the late 2000s had just backed away from considering a significant investment in the surface of the moon. So without that momentum, again, speaking from an infrastructure standpoint, it would be very hard to draft your own path to the surface of the moon and build out a business there. It's not that it's impossible, just harder than the alternative in 2009. So today, with the US reaffirming their now current interest in the surface of the moon, and certainly with the Chinese-Russian collaboration having that well within their roadmap, I think lunar surface activity has the potential to be this catalyst. And I'm just very hopeful, and I'm saying a lot of things loudly to help guide investments into things that help it scale the best for everyone. So that's not a date, Jim, but I think it is well within our capacity to be beneficiating lunar surface material by the end of this decade. And that's a lot different than making orbital propellant depots here between the moon, but simple things like berms, radiation shielding, power systems on the surface of the moon, all of that's made incrementally easier by using as much as we can of the stuff that's already there.
The book I mentioned, just happen to have a copy here, goes into some detail about the emergence of a market in low Earth orbit. And I agree totally with Chris that that's what will stimulate commercial sales in space as opposed to selling to NASA or someone like that. And we mentioned tourism, but I think the advent of the Axiom space station and perhaps others will make a huge difference. It's going to be much easier to do research there, and individual scientists can go up and do their own research there, which will be 10 times more efficient than having a rapidly trained astronaut. It's like having a new grad student work on your project. It's just not the same as having an experienced researcher. So I think that's going to make an enormous difference. And there are experiments on the ISS on manufacturing. We've probably all heard about the ZBLAN optical fibers, which might be manufacturable, seem to be promising. Also, building human organs in space, like eventually, possibly a great way to build human hearts, and the human heart is less than 1 kilogram, so cost of transport is just not an issue. So there's a lot of very exciting possibilities that are coming on. By the end of this decade, I think we'll know which ones are going to work, and that will create the market.
So I'd like to propose that we consider the bullish version. First of all, anyone who thinks they know the answer, they should go out and make $1 trillion. But it's clear that Elon is scaling to make thousands of Starship flights in the 2020s. the objective of the launch vehicle industry is to, and the physics tells us that launch to space can drop to only 10 times that of air travel in the 2020s. When that happens, the amount of traffic in low Earth orbit will be gigantic, and there will be thousands of people in low Earth orbit all the time. I mean, this is one of the reasons why Transastra has always had the plan, which appears to be a pivot, but it's just step one in the plan, which is to accelerate our activities in low Earth orbit, why we're building Worker Bee right now. How soon we go and mine asteroids or the moon depends on what the market says. It's highly nonlinear and unpredictable because, you know, as Alan Kay said, the best way to predict the future is to invent it. It depends on who the inventors are and who the investors are that make it happen. But I can tell you that, you know, we're turning away investors in large numbers right now. And there's a lot of money ready to go into space. Humanity has made the decision to go into space, and the investment markets are driving that. So it could very well be that it'll happen bigger and faster than we think. And I think we should hold open that possibility. I think, you know, thinking in a 20th century way, you know, it'll be 100 years until we have, you know, 100 flights a day into space. We may have 100 flights a day into space in 8 years. And if so, there's going to be gigantic markets. The other thing is, the NASA approach to systems engineering is poisonous. It's based on 20th century technology. Remember, before we invented modern systems engineering, we built the Eiffel Tower in 1 year without computers or hydraulics. Today, with modern systems engineering, it takes 10 years to build a high-rise. What Elon is doing is just applying good, solid engineering practices and team leadership. And there are lots of people who are learning those methods.
It's more about minimizing risk than maximizing opportunity.
Right. And, you know, it's like being out of NASA and JPL now for many years. I wasn't aware how fear-based everything in government is. When you go to a meeting at JPL with a wild new idea, 10 people tell you why it's stupid. And 3 of them are gatekeepers that stop the idea.
So Joel, sorry, but just to your point, do you know how long it took to develop the mRNA COVID vaccine?
Well, it depends on where you fire the starting gun.
Okay, so in the exact fair point. I mean, 20 years of R&D, but apparently I heard it took 3 days to actually develop the vaccine itself, a period of time for testing before then releasing into the wild. But to your point and to Chris's point, when we look at some, you spoke of 10 years for a high rise. I've heard of high rises in China going up in weeks.
Exactly, no bullshit.
Right.
And
you know, they just get on with it. And I think, you know, it's imperative based. It's risk reward based. If we somehow are able to communicate the existential knife edge that we're actually living on as a civilization today, at least let's say there's a probability that we're on an existential knife edge with climate risk, with our, let's say, socioeconomic irregularities and inconsistencies. We need to move like there's no tomorrow. And we see on a multi-trillion-dollar impact of the pandemic and how by not dealing with it collectively and aggressively, billions or tens of billions of dollars of prior investment turn into trillions or tens of trillions of dollars of cost in the rearview mirror. And we need to take these lessons on the pandemic, apply them to climate and civilization stability, and really push this message home so that we can develop forward into system of space and beyond.
I think if you look at, you know, this through the lens of like old space and the way things were done, and certainly the risk appetite of, you know, how space programs have been developed, yeah, it's going to take forever for us to get anywhere. But, you know, if you start looking through the lens of robotics and a more iterative design approach, right, and a tolerance for risk failure, you know, we assume that the missions we're going to put up on the moon are going to fail at multiple levels, and we are going to continue to learn from each one, continue to iterate. That is why I'm not sending people, I'm sending robots, because, you know, I'm assuming they're going to die. And so, you know, but between that and the amount of capital that has flowed into the space just over the past year, there's been unprecedented capital inflows. If you look at the SPAC transactions and everything else, this is really a paradigm shift in space. There is more capital. We are on the cusp of a private industry that is no longer, you know, reliant on the government here. This is not going to be led by the government. It will be partially kind of de-risked by it. And then if you add on top of that what's happening with China, right? If you had looked at the timelines for lunar development 9 months ago, they were completely different than they are now. When China landed that lander and then announced after that that they were going to build a moon base with Russia, that is a paradigm shift for exactly what happened here. So, you know, things are changing. There are future events that we have not predicted that will be exactly like that Chinese announcement and Chinese mission that will just accelerate this in ways we cannot predict.
You know, as long as we're talking about risk aversion and we're hawking books, somebody wrote a book about this. You get it to, doesn't want to too shiny or something.
Jiggle it if you wanted to. Jiggle it.
Jiggling is the problem, I think. There,
What's it called?
it's called "Safe is Not an Option." Doesn't want to show.
Well, it's very stealth. Anyway.
To the failure is not an option, Kip. I think a lot of the message here is that, you know, failure is not great, and there are certain circumstances where we would like to completely avoid it. But it's not about elimination of failure or mitigation of it. It's about resiliency to the path of failure. How do you build a certain amount of mistakes and things going poorly into your plans? How do you make it okay that it doesn't work out the way that you expect it the first time? And you know, an easy example, you know, Elon talking about 3 launches of the Falcon 1, and he was going to throw it in. Good thing that he was able to do the 4th, because he's been able to build a pretty successful company as a result of that. So the challenge in space, I think, still is it is more expensive than other industries to iterate, but that doesn't mean it's impossible. And the best business models try to figure out what the right balance point is between that iteration and the market it's attempting to serve.
And Elon's demonstrating that every day down in Boca Chica. You know, he hopes the rocket will work, but he doesn't expect it to.
Yeah,
And he learns every time he fails.
I think it's healthy to push back on the assertion that failure is more expensive in the space industry than other industries. So what is expense? It's work.
It doesn't have to be.
Yeah. So what is expense? It's work hours. So the rover that JPL recently put on Mars cost $1,000 a kilogram, in excess of $1,000 a kilogram of workforce. It was very expensive to not iterate that. In software, you know, people say, well, it's cheap to fix software, but in fact, when you create bugs in software, fixing those bugs requires engineering workforce to fix those bugs. And rebuilding hardware in the space industry is only about 50%. Only about 50% of the cost is hardware. It's mostly the engineering time. So Chris, I think your point about that is very thoughtful, but I think we need to revisit that assumption. I'm not sure it's true. I think you can't plan a development project on the basis of planning for failure. What you do is you do a plan which is based on an assumption of all green lights to Malibu. All green lights to Malibu is something that never happens. And you know that, but what you do is you create a culture where failure is not viewed as a disaster and it's expected, and you're always adaptively responding.
That's my point. Rather than doing it in one huge increment, all greens lights to Malibu, how do you figure out what are the increments that you can experiment on that are a better optimization of work and cost?
Yeah. And so, and what you do is you create a culture where people are just experimenting and testing all the time and breaking things in the lab all the time. It's like when I go and visit my engineering team, I say, what have you broken lately? What? Why not?
And they say your laptop.
Let me take a question from the audience. This one's to Jim, but others can answer as well if they have one. What do you mean by service to orbit-based pricing? How does that work?
In the context of accelerating, let's say, a large-scale business in space with grand objectives, building or manufacturing is harder than service-based provision if infrastructure exists. So a service-based business might be, for example, use existing Earth imaging satellites, obtain access to their data feeds, and provide additional intelligence layers and value add on that product, which you can sell immediately to existing customers. That's something you could get up and running in a 3 to 6 month period if you understood a value proposition and a market need. So it's basically the steps are, if you can't build infrastructure beyond geostationary, beyond the market chasm, pull back, build infrastructure at geostationary or before the market chasm. If you can't do that, pull back, build infrastructure in low Earth orbit. And if you can't do that, build service either in geo or in LEO and apply it to Earth markets. So just kind of, I was alluding to reduce the scope and the size of your business proposition so you can activate business. There's no such thing as a space business. There's just business. So get going with that first and build up the extent into the space domain as the market need dictates.
We have sort of a legal question that a lot of people are asking in various ways. People who are not US citizens want to get involved. And how is it, are there difficulties with getting involved in this industry? We know there is in launch. We know there is in ITAR protected things, but is there a problem for what you guys are doing? Can you hire for us?
I could answer that very quickly before Chris might jump in. Offworld has several Offworld overseas subsidiaries. So for non-US persons wanting to get involved, there's room for growth, and we're hiring both in Europe, Africa, and Australasia.
That's great.
We don't have those issues in Canada, so come on over.
Anybody else?
We're hiring Americans.
Just to talk as the challenges of a founder and CEO of a company with US laws is, well, it's not too difficult to integrate people outside of the US into a business activity. For a startup, it creates a big overhead because now you have part of your business that needs to keep track of a bunch of set of rules, maybe for one individual or two, and then you have most of the rest of your business which doesn't have that restriction. And then you have to actively spend time on being careful about the mixture of the two. And some of it falls to like facilities. You can't have same activities going on in the same room where people can get access to them. I will refrain from comment on whether any of that makes sense. It's just currently the law. And it's a little bit of the background between one of the reasons why it's generally the larger companies in the U.S. that have enough of a footprint that are able to mix those things in. So apologies in advance on behalf of U.S. policies for everyone else in the world who would like to engage with us American citizens.
Well, Elon's gotten caught between the gears on that himself, right? You know, with the person who was suing him because he wouldn't hire a foreign national, even though it was against ITAR. So he's between a rock and a hard place. And here's a interesting question. Does incenting harvesting metal from holes with ships and debris in space actually incent a marauder economy, and thus the depravity of our society as pirates scavenge the stars? Let me ask you a different way. And I do worry about reavers sometimes. But I wanted Chris to respond. You know, are it's a different, one thing to mine the moon, it's another thing to mine a body that was put up by a state's party that continues to carry responsibility for it.
Gary
How do we
should
deal
speak
with
to
that?
not me.
And
Well, both Chris and Gary, I guess.
You're talking about Chris Johnson, right?
Yeah, Chris Johnson, multiple Chris's here. Sorry.
Oh, sorry. Yes, Chris Johnson.
I mean, as far as the first question goes, I think there's enough regulation in place around, you know, you can't just go, even if we are creating value out of debris, you're not going to be able to be permitted to go after something without permission from the launching state and the, you know, alternate owner of that property anyway. So we've always gone on the assumption that we would only be able to operate with permission for harvesting resources from, you know, space debris.
Well, that's the question then. How do you get that?
Yeah, I'm gonna throw one probably to Chris's side of the net. I think there is a chance that the Outer Space Treaty will come under such pressure just through the weight of precedent over the next 10, 20, 30 years that we may see either amendments or additional treaties or regulations forming that will answer some of these questions.
I think it'll happen quicker than that. I mean,
Well, Chris, what do you think?
Oh, Daniel, you had a hot pursuit response. Please go ahead.
no, just like we're already on the, I don't think 20 or 30 years, like it's already at the point of breaking, right? None of this really envisioned commercial state actors. This is all going to be resolved in some capacity. I have no idea what that looks like. Chris is the expert here, but you know, in the next 10 years, there's going to have to be some consensus as you look at the timelines of what's happening on the moon and elsewhere.
Well, shortly I'll talk about, you know, the debris and removing debris where we can identify the launching state. We can ask for permission. You know, it's a large piece. We can see who launched it. That's different from the small stuff that we want to remove. We don't have salvage rights in space. We likely will need salvage rights in space. But the good news is I think that regulators are open to those types of discussions, especially because they assist cleaning up the space domain and they assist space sustainability. So long as this activity takes place in a transparent and safe and non-escalatory fashion, because there's significant security implications of having that type of technology. But I think it's possible. And then the case is easier when you can identify the launching state, which still owns that piece. In you know, larger context about viability, future proofing of the Outer Space Treaty. Look, the Outer Space Treaty is not going anywhere, and I don't think it should go anywhere. But I always talk about the modest aspects of the Outer Space Treaty where you ask a question of it, it doesn't give a clear answer. Deficiencies in what the law is. And in that respect, that's where national legislation fills in and where we will not have at the international level new treaties, but certainly the possibility for the development of non-binding principle statements. You can look at the LTS guidelines. You can look at the IADC space debris mitigation guidelines. You know, I predict that probably in the next couple of years, and this was answering someone's question, what will happen at COPUOS for space resources? I would not be surprised, because they operate by consensus, that the consensus that they reach is that it is permissible to do these things, and that there's going to be something that has to be offered to the rest of the international community. But whatever they develop will be not a new treaty, but will clarify, elucidate the deficiencies that we have in space law. So that's what I predict.
Here's one more. We don't have a lot of time left, but the question is about how do we keep, going from legal back to technical, how do we keep the regolith out of the habitation site because of the toxicity of the lunar dust? I assume people have thought about that.
Don't leave the habitation site.
Well, that's no fun. It's like COVID, 24/7, 365, right?
Look, guys, the airlock is going to have to be a clean room.
Yeah.
It's going to have
a dust room instead of a mud room.
exactly. It's a practical question. That's when you build a hotel or a significant outpost on the moon, it's a real problem that we have to deal with. And but there's engineering solutions to it.
I know that our time is short, so I'll briefly make just a minute of remarks. Is that in the governance regime that we have, there is no ordering or hierarchy of activities on the moon. So your commercial activities, whether it's mining, are of the same nature, both as permissible as scientific investigations and putting telescopes and cold traps. Space law doesn't have a hierarchy of it, but we will need to have a discussion with regulators and with governments as to what happens where, and the characteristics of that type of activity in a way that conforms with international law, doesn't create tensions between states. So there's a lot of discussions that have yet to happen, and a lot of patience is going to be required, and understanding the narrative that the new space industry has and its perception, with the rest of the world has to really be seriously thought about. Lastly, in my remarks, I mentioned that some regulators have a mandate to foster commercial space. That hook, that anchor, is something that will need to be exploited and really utilized. Find regulators that want to foster commercial space and want to say yes to your activities, as opposed to regulators that are looking for excuses to say no. That's all.
Well, go ahead, quick.
Quickly, I think as industry, it's incumbent upon us to push back on regulators and let them know that, at this point, that is really what is holding back in many ways these industries. They are sensitive to that message. And I think that's an important message for us all to communicate in our respective jurisdictions and conversations, because again, this is a problem we all need to solve. This isn't one company's problem. This is the world's problem. That now is the time to be updating these regulations and probably iterating upon that, as things evolve.
With regard to that, let me just make an announcement that Paul Steimers, who is a lawyer at K&L Gates and a lobbyist, has done a lot of really good work writing legislation that's very helpful in this area, is starting a space resources industry group. And he's asked me to help from an industrial perspective to help coordinate that. And so it's vitally important that the right words get to the right policymakers to encourage effective space industrialization with proper stewardship and ethics. And so our philosophy is very market driven, minimum but necessary regulation as needed to encourage ethical exploitation, ethical use of the resources for the betterment of the economy and humanity. So if people are interested in that, they should reach out to me. I posted my LinkedIn there. Also, you can go to the Transaster website, use the contact form, and I'll put you in touch with Paul. I would love it if everyone on this panel would join that. And I'm inviting you to join today.
And following on from that, that's a great gathering, Joel. The Moon Village Association, which is an international non-for-profit body, has formed a working group following on from the Hague Space Resources Activity for industry coordination on the lunar surface and in cislunar space around a number of aspects of standards, interfaces, operations and best practices, which I think there's at least 30 to 40 nations represented now, and representation into COPUOS. And this, I think, is going to be a strong interaction and point of coordination. And so, you know, the work that Joel, you're doing there with that working group as well, all of this, I think, will feed together as we start to get the results of these deliberations and coordinations. It's all very important.
Well, we're out of time, unfortunately. I could easily do this another hour, but that's a good note to end on, I think, you know, because I think that's going to be one of the big barriers. It's probably certainly not finance at this point, right? And the technology is coming along, but the regulatory issues, the governance issues, and you know, Open Lunar is working that as well, you know, Jesse K. Shingler. So that's probably a good note to end on, that we shall get more involved in helping forge the policy that we need to move forward on this stuff. And I want to appreciate again, thank everybody on the panel, and hope all the audience enjoyed it.
Thank you, Olaf.
Thanks, guys.
And all panelists, if you don't mind sharing the presentations, we will actually text you about that, and we'll put them on the website because people were asking. And thank you very much. Space Technalytics is grateful, and personally me, for having, like, that you actually devoted your time here. That was great. Thank you.